Okay, so on number 12, we're going to move into actually calculating some limits. Instead of looking at graphs, we're going to look at the equations. You do have some limit laws in 2.2. I would encourage you to look at those because those limit laws tell you that when you have a limit like this on number 12, that a limit of a polynomial is equal to the limit of each little tiny individual part. So the limit laws, while we don't in practice typically split limits up like this, and I'll show you why here in just a second, the limit laws will actually allow us to break limits up like this. So the limit of a polynomial is equal to the limit of each part. And then we can keep on breaking this down with the limit laws. We could take this negative and put it out in front. So we'd have the limit as x approaches 2 of x squared. We could also take a constant and move it in front. So the limit laws are very helpful in times where you have a situation where you want to move something out in front or look at the limit a little bit different. But for regular polynomials, it's going to be a lot easier just to calculate them. So if we look at finishing this one out with the limit laws, though, we'd have negative, and then what we do as x approaches 2 for x squared, all you do is you plug in 2. So we're going to have 2 squared. And then we have plus 5 times the limit as x approaches 2. So we would just plug in 2. And then one of the other limit laws is the limit of a constant, which is what we have here, is equal to the constant itself. So this limit is going to be equal to negative 4 plus 10 minus 2. So 6 minus 2 is 4. Okay. In practice, though, what we're going to do is typically just plug in the value. So for something like this, it's going to be a lot easier if you just practice trying to plug in the number first to see if you can evaluate it. If you can evaluate it directly, that is definitely the easier thing to do. And of course, you can see here we got the same thing that we had the other way. So we're going to get 4. So you don't have to use the limit laws to break these up every single time. But the limit laws are introduced here because later on you will need to use them in certain instances. Okay. So on number 20, if we try to plug in 4 directly, we get the square root of 4 squared minus 10. So that's the square root of 16 minus 10, so square root of 6. And I would leave those. Leave your rational or your irrational answers just unsimplified like that. Or they're simplified, but you don't have to convert it to a decimal. Okay. I will spit it out eventually. Now, on number 22, if we try to plug in 0, we actually end up with a little bit of an issue here because we can't divide by 0. So that's our problem on this one. So we have to look at this and we have to say, well, maybe let's try some algebra, and let's see if algebra will let us restate this enough that we can look at it a little bit differently. So when you have a square root, usually the easiest thing to do is multiply by the conjugate, which, remember, conjugate means same thing, just different middle sign. And we'll do that on the top and the bottom because then that makes it a legal move. And we get limit as h approaches 0. When we take a square root times itself, it gets rid of the square root. Nice thing about conjugate, outside, inside are going to cancel. So this is what we've got left. And then the plus 4 minus 4 are going to cancel. And then we've got 5h over h, and we can further reduce that because the h's are going to reduce. So what we end up with is the limit as h approaches 0 for 5 over square root of 5h plus 4 plus 2. That we can plug in 0. So we get 5/4. So sometimes you have to use algebra to restate these a little bit so that you can plug a number in.